Hi everyone, so we're going to start today's lesson talking about biochemical cycles. Please take a minute to watch this video. I linked it in the daily agenda as well. But biochemical cycles, we're going to see that bio, geochemical mean three different things. So bio is going to mean our Earth, life on Earth. Geo is our rocks that we see, and chemical are all these different chemicals that we're going to talk about and that were talked about in that video as well. So one thing I want you to consider here are different products that you recycle and where those products come from. So those products are going to be really important here, as well as where we think about they have been recycled. So nutrient cycle is something that we're going to be talking about, and that's how matter moves through our atmosphere. So when we talk about matter, it's more of a tangible thing. So all those carbon dioxide is not as tangible as maybe glucose, but it's something that we're going to see here. Another really important thing to note here is that matter cannot be created or destroyed, but only transformed. So when I say transform, that's changing states. So when we think about our carbon cycle that we're going to talk about in just a second with photosynthesis and cellular respiration, in photosynthesis we're taking carbon dioxide from the atmosphere and making sugars. So we're taking something, transforming it into something else. In cellular respiration, we're doing the exact opposite. So we're taking our glucose and transforming it into carbon dioxide here. So it's really important to note here that matter cannot be created or destroyed, only transformed or transferred. Another important thing here are nutrients in our organisms are required for life. So we're circulating through all of these different nutrients like carbon, oxygen, nitrogen, and phosphorus for life to happen. All of these different things are important for life to happen, and we can see that with, again, our abbreviation SNOPS. Carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Those are our really important elements that we're going to see within our organisms here. So carbon and oxygen, hydrogen and oxygen usually go together within our water cycle. So let's take a look at our carbon cycle. Some of our important things here that we're going to see: photosynthesis is taking energy from the atmosphere and transforming that carbon dioxide into sugars, which is going to be used in respiration by animals and humans and things like that. Another way we're taking our carbon from our atmosphere or from our materials is through erosion or the use of our natural gases or coals here. And usually with an erosion, we're going to see that carbon dioxide is going to be dissolved into the water, and the use of our natural resources is going to go to combustion. We also see decomposition helping with bringing that back into our different plants and animals here as well. So with decomposition, we're taking those dead organisms and bringing it either into the atmosphere or into our ground with limestone or natural gas or oil and coal, all those different things. So if we take a look at our carbon cycle, we're looking at the movement between non-living things and living things within our environment here. So all of those things are going to be taken. Non-living things like air, water, and rocks are moving into our living things, which are animals and plants, and then back and forth as we see that cycle happening. Carbon is one of those super essential elements because it's found in all living things. So proteins, fats, and carbohydrates, those are going to make up all the organisms on Earth. Carbon exists in air, water, and living organisms, and we can see that through our processes here with photosynthesis and cellular respiration. So producers are going to convert that carbon dioxide into carbohydrates through photosynthesis. So we're taking carbon dioxide, converting it into carbohydrates, and we can see that with our formula down here. And then consumers are going to take that carbon from carbohydrates and bring it back into the atmosphere, usually in the form of carbon dioxide. During that cellular respiration, we're going to see that carbon released as carbon dioxide, like I said. But we can also see some of that carbon stored in limestone, which is going to form a lot of our carbon sinks. So limestone is one of those rocks that really preserve our fossils, so we're going to see a lot of our fossil fuels coming from that limestone as well. But one thing I really want to emphasize here are these formulas and how they are opposite reactions. So in photosynthesis done by producers, we're going to see that our carbon dioxide is taken using water and solar energy to make glucose and oxygen. And then our consumers in cellular respiration are going to take that glucose, use oxygen to break it down to make chemical energy and release water and carbon dioxide back into the atmosphere. So really write down that equation there. If you have any questions, please feel free to reach out.